I just want to say thank you for coming out. I know a lot of you have traveled in from near and far, especially always in the Bay Area. It's a challenge to get here. I came in here yesterday. I actually flew in from Seattle. The flight was about an hour and 20 minutes, but it took me about an hour and 15 minutes to get from San Jose Airport to here. So the traffic in the Bay Area always never ceases to amaze me. Look, we've been on an amazing journey here with this whole evolution around software-defined networking and open networking. And you know, if you go back to 2011, which seems long, long ago, ONF was formed to do something really novel, something special here, and that was to promote a whole new approach to networking. And we called it software-defined networking. And it was a bold challenge. And at that time, SDN, you know, was just really still getting defined. And for many operators like us at AT&T, we were trying to figure out what it meant to us and where should it play in the future of our networking aspirations. But we all saw a need, and we really didn't have a choice, because when you look at when smartphones were introduced, it really just created this demand surge across our networks that really changed everything. You know, the data traffic on our mobile network, if you go all the way back to that first iPhone launch, has grown over 470,000%. And that's pretty phenomenal. And guess what? That growth curve is not slowing at all. In fact, as of today, we haul about 274 petabytes across our backbone every day. And I remember actually standing on a similar stage like this just a few years ago saying, wow, we just hit 50 petabytes. And we thought that was a big deal. So it is just, the tsunami is just continuing here. And we all know this old model that we've been in, you know, just doesn't scale anymore. And back in 2014, AT&T, under the leadership of John Donovan, went out and made a big proclamation that, hey, at AT&T, we are going to convert our network to a more virtualized, software-defined controlled network. In fact, we're going to move 75% of our functions and traffic to this new paradigm. And I'm proud to say we're on target by the end of this year to get to 70%. In fact, just yesterday we announced, if you look across our MPLS-based network, 75% of our data traffic today now, our MPLS tunnels are under SDN control. So we really have taken a long journey here and made it happen. And we're really proud as we come up onto 2020 of hitting this 75% goal. So a lot going on there. And with that, there was no way we could have done this alone. We really needed the help of a community. And that community really was this ecosystem that we needed around SDN. And that's where ONF comes into play here. ONF has been at the heart of this ecosystem. And many of these projects, many of you in this room that are a part of, that are leading and participating in this day in, day out, are really helping make this dream a reality. And I'm really proud to see, and you're going to see throughout the day, throughout the entire conference, the amazing progress that has been made. And then also you're going to hear a lot about some really great future here in terms of these projects actually going into production. And it's not just with AT&T, but it's really with many operators around the world. So we're really excited about this. The ONF model works because it's a community, okay? And it's a community that's led by the operators, okay? typically when you look at these, the other open source communities out there, there's a lot of those that are led more by the supply chain. This ONF is unique here in the fact that it's actually led by operators. Absolutely, we have the supply chain in there. But this helps us to prioritize and define the use cases that we believe matter most to our end customers. And we believe that's the most effective way to make this happen. So network operators such as AT&T, Comcast, China Unicom, Deutsche Telekom, Google, NTT, and Turk Telecom are really good at specifying and defining what these use cases are and the solutions that they need and what they're going to commit to deploy. And that's what makes this ONF organization so successful. But what really is at the heart of those operators that surround this heart is the ONF team. And this is really, it's a small but very mighty team of some really talented architects and engineers that make this happen. And I'm also really proud to say it's also led by, although maybe not so tall in stature, but mighty in leadership, an amazing leader, Guru, that makes it all happen. And Guru has just done a really super job of getting all of the cats corralled here and aligned and all the efforts prioritized to make sure that ONF is delivering as much value as possible to its constituents and to the community. And so I want to just give a round of applause here to Guru and the entire ONF team. So let me talk a bit about some of the projects that you're going to hear a lot more about. There's some really amazing workshops going on, as well as demonstrations. And what amazes me is just how fast things are going now. Just yesterday we had our board meeting, and I learned about some new projects I didn't even know were going on. And then frankly, they said, oh, by the way, we've got a demo that you can see it in action. And so this is just a testament, I think, to the speed and the agility that software is bringing and enabling to the community. So it's really exciting. So I just want to highlight a couple projects here. You're going to hear a lot more about them, but these are our hallmark projects that, it wasn't so long ago, they were just, papers and PowerPoints and talk. And these are now projects that are now going into production, that are already in production, and scaling and serving thousands and thousands of customers. And this is really exciting. So the first one I want to highlight here is Trellis. And Trellis is a project here that's all about an SDN-based leaf spine fabric. And that Trellis, and you're going to hear more about this, I don't want to steal anyone's thunder, but this is going into a large tier 1 operator that's really taken this, and it's been an amazing learning experience for us. Trellis basically uses OpenFlow enabled white box switches and couples that with a control plane that's powered by ONOS, as well as some other applications. And it creates a highly scalable, highly robust, distributed leaf spine fabric. And I think you're going to learn more about how powerful this is. And it really is a great testament from the standpoint that it validates the production readiness of both ONOS as an SDN control plane and Trellis as an SDN fabric. And that is something that's going to really open the door up to many new capabilities down the road that ONF is working on, and I'll touch on those shortly. Another great big project that's going on is SEBA, and that's our software-enabled broadband access. Now we have multiple operators and suppliers that have been partnering on this, and not just SEBA, but Voltha and we have an acceleration plan to get CEBA 1.0 stabilized here for operator deployments in the coming months. So a lot of excitement going on there. Here at AT&T, we have a deployment underway of XGS-PON using CEBA. We have it in trial right now in Irving, Texas, in Atlanta, Georgia. We've got about 500 to 1,000 homes passed on this technology, and we're really excited about it, not just because it's helping us with delivering gigabit plus speeds and services to our customers, but it's also a technology that's really access independent. So the beauty of this architecture is it's been designed and architected that this can extend to not just fiber access, but multi-modes of different types of access. Think of fixed wireless, think of G.fast. I mentioned and a variety of different PON technologies as well. And so that to us is very powerful as we build out our networks. And it's also an architecture that's, it's supporting this whole notion of convergence. And so there's a project here, our COMAC project, which is this converged multi-access and core project that we've pulled together with CEBA that's allowing us to get a converged user plane across both wireline access and radio access and our core, our mobility core. So it's pretty powerful. Additionally, it's allowing us to build extensions into some other really important open source projects that we have underway at AT&T. For example, Acrano. Acrano is an AI-based community out there, and we're building a blueprint here where we can plug CEBA into this. So now we can take advantage of all this visibility and control and run it through machine learning and AI algorithms so that we can do more creative things in terms of how we develop new services, but also how we operate them. We're also extending this to the radio edge. And so this is also creating a blueprint here for how we can plug into O-RAN, which is, again, another initiative out there. And we actually have an effort underway to build an O-RAN-based near real-time RAN intelligent controller. So this is kind of like a big Lego block puzzle that we've been putting together here. And also, we are working with ONAP, which is our orchestration framework, to also integrate in with CEBA as well. And this is going to help us drive a lot of operational efficiencies in terms of how we manage and automate our networks. So a lot of great work going on here with CEBA. I want to touch briefly on another project. We call it OMEC. This is the Open Mobile Evolved Packet Core. Intel and Sprint and the ONF community have published an open source release of an almost production-ready CUPS compliant mobile packet core. And ONF and the community are working with Deutsche Telekom and Sprint to do a trial deployment of OMEC with live customers before the end of the year. So again, this is just showing how the extensibility of this architecture and these projects are spanning across wireline and wireless networks. So very exciting. Also, more on the future-looking side here, Stratum, thanks to Google, Barefoot, Broadcom, and the wider community of white box switch vendors, ONF, in fact, I think it was yesterday, we released Stratum into open source. And we're really proud of that. Stratum is a thin switch OS supporting our next-gen SDN interfaces, namely P4. Think of P4 runtime. Think of OpenConfig and other interfaces. And we're demonstrating Stratum on both Broadcom's ASICs as well as Barefoot. And this is really exciting because this is really bringing the support for truly programmable forwarding with white boxes. And we're doing this with a lot of white box vendors out there, but namely EdgeCore, Delta, Quanta, Dell, and Ventec, and Stortus. And so while the focus of the ONF community with Trellis and CEBA and OMEC is getting these open source platforms out there into our operator networks, our production networks, Stratum is actually creating this foundation for the next gen SDN stack, okay? And this is where the next gen ONOS is evolving, as well as Trellis. And this is what's going to get us to give us a nice bridge to start enabling this real-time, fully programmability control all the way through down to the silicon. And that's how all of these pieces are fitting together. So we're really excited about the capabilities in the future here of what Stratum is going to do and how it's going to help position and drive ONOS and Trellis and CEBA into the future. I talked a little bit about P4 and how important that is. Earlier this year, we announced the merger of bringing P4, p4.org, into ONF. And we're hosting all the P4 activities now in working groups. And P4, it's not just about expanding the ecosystem, but it's also about maturing it. Because as an open source programming language, P4 has become essentially the industry standard for describing how switches and routers and NICs process packets. And ONF gives P4 a great platform that it needs to continue to develop and grow, just as us operators need to continue to develop and grow ourselves with these technologies. Also, back in the sort of mobile space here, we have SD-RAN and multi-access edge cloud. We're continuing to pursue SD-RAN. A lot of exciting things going on here. This is, in other words, think of this as our Cord platform. China Unicom has publicly announced that they plan to take SD-RAN and edge cloud into trials here over the next several months. So we're excited to see their developments and see what they can bring back to the community there. So a lot going on. You're going to hear a lot more details about this in the next several talks. But I just want to tie this back to, 8 years ago, we were all trying to figure out what SDN was exactly and how it was going to solve all of these network challenges that we have, the 470,000% growth. But really, SDN is now becoming the network. White box hardware coupled with open software creates this disaggregated, virtualized, and software-controlled environment that finally gives us a chance here to survive all of this growth and change. But it does more than just that. It really allows us to get ahead of it. And that's what we're so excited about. And this is very timely because think about it. A lot of operators like AT&T, we're deploying 5G. And you can expect 5G to be mainstream next year. And you can only guess that data demand is only going to go up with those increased bandwidth speeds. And when you think about all these use cases out there that we haven't even come up with yet, that surge of demand is just only going to continue. And we're going to be even more reliant on SDN helping us solve that. But the reason we're ready is because of you and your help, your participation, your contributions are making this all happen. And I know we just got to keep going, so don't rest. It's only Wednesday. It's a long conference. We got a lot to figure out here. But we got to keep growing. And I need all of you to keep pushing the boundaries here and help grow this ecosystem. And I know we're up for the challenge. And I just want to thank you all for what you're doing, because this has been an amazing journey. So thank you very much for your time, and enjoy the rest of the conference.